Continuing on into Unit 7 before we get into geometry and statistics. So in Unit 7, we're going to be looking at scenarios that were given, such as these word problems, and we're going to try to find an equation that would represent the relationship, also known as a sequence, or what we have been calling a rule, so that we can create tables of the information that's given. As we get into the lesson, we always want to pause and look at the goal objective for the lesson, what it is that they want us to learn, and that is the idea that I can use variables that will represent my independent and dependent values. Now that goes back to lesson 7.1, right? So just a reminder, when we talk about independent and dependent, what we're talking about. The independent is what the book also calls an input. You'll see that on your standardized test on NWEA and on future lessons as well as in middle school. So remembering independent and input, they kind of go together because they both start with the IN. Now, what that means is that's the variable that I'm going to be able to use in my math problem. Something's going to happen to it, but it can change according to my scenario that I'm using. So the example that we saw in lesson 7.1 was when we were talking about playing video games at 25 cents a piece. The 25 cents was a constant, and we used a G to represent the number of games that I could possibly play. The dependent then is the output. We also call it an answer because it's what we're going to end up with. It depends on the input, what's being done inside the math problem. And going back to that lesson 7.1 example with the games, then we used a C for the total cost. If I spent 25 cents for 8 different games, how much was my C, my total cost that I was going to spend? The second goal to this particular lesson is then being able to write a one-step and a two-step equation. Now, we call that a rule oftentimes, right? And earlier on in our book, we talked about rules, and that's just the repeated algebra, the repeated math that's going to happen. It's also called a relationship here, and we saw the relationship when we were plotting things on a coordinate plane. It's also called a sequence, which we'll review here in just a moment from earlier years. But it's just what math will be repeated consistently. As always, they give you an overall example that we can look at. So they give us this D is equal to 8H. Now, what I want us to remember is something that we learned early on this school year is the idea of fact families. So specifically with this scenario, we're talking about fact families of multiplication and division because sometimes I'm not given a piece of information and other times I am. So when I would be finding this rule, I'd want to figure out what I'm doing to the 1 to get the 8. And then what am I doing to the 2 to get the 16 and the 3 to get the 24? And they tell us then the rule is D, the final answer, my dependent variable, is going to be equal to 8 times H. So I know that I can take 8 and multiply it by my hours and get my answer. The reason we're looking at fact families is because that can also be switched in the other orders, but sometimes they try to trick us and they give us a rule and they give us an output, but they don't tell me how many hours there are. So if I know how my fact families work, I can still take the information that I'm given, knowing that my output, my dependent variable, is always going to be equal to the math that's being done. So if all I knew was that I was going to multiply 8 by something, but I don't know what those hours are that they give us there in the middle, then I can just rearrange those. And I can take my D, my final answer, divided by the H and get 8, or just simply take the D divided by the H to get the number of hours, which would help me find that first column. So it's just manipulating those around in a mathematical consistent way that will help me find. So let's look at this example as they start to ask us questions about patterns and what we will talk about as sequences. Right? So when we look at the output values, right, the answer are going to increase by the same number, and they tell us that that is 9. So once again, when we talk about output, we're talking about our dependent versus our independent, right? And since we're talking about what we're going to label them, I know that my independent, my thing that can change, is my t-shirts. So we represent that by a T. And my output is going to be represented by a C because I have a total cost. So they're asking me is if I use the rule of 9t, which is 9 times t, do I get the correct answers that I need? So they're basically asking me, is the sequence correct? So now I've said that a few times. And this takes us all the way back to second, third, and fourth grade, where we're really focused in on sequences. We sometimes call them patterns, right? How is the next number changing, and is it changing each time by the exact same thing? And when I look at that example about the t-shirts, I see that it does increase by 9 each and every time. So the rule of C, the cost, is equal to 9 times. Let's get into working through some examples. So when we look at the problem, once again, we're going to cube it. We're going to mark some information that is important. We're going to also underline the question that's being asked. And the first piece of information that I've given, it says the table shows the total cost C. And that means that total, that is my keyword, then that means it's going to be equal to. So I know that has to be my dependent variable. That's going to be my answer. And then if I know that I'm looking at the idea of having a T, a number that I'm doing math with, to equal my souvenirs, my t-shirts, then that's going to be the independent variable that I'm using inside the math problem. So what I'm being asked to do then is I underline it, says write an equation to represent the relationship between C and T. Can I find a rule? Can I find a sequence? Can I find a pattern that's happening and write it as a math problem? Well, before I do that, then knowing which is my independent and which is my dependent variable is what's important. So I know that my independent variable is going to be T for the number of t-shirts. That's the one that has to have the math done to it. The dependent, that's my answer. So that is going to be a C, which is equal to my cost. Now, here's a note that I would like you to write down, this and then the one I want to put up next, because this is important when it comes to figuring out sequences or patterns or relationships, the rule that's going to happen. If I'm going from a smaller number to a bigger number, I am going to be adding or I'm going to be multiplying. Where if I was going from a larger number and I'm getting smaller, I am decreasing, then I am subtracting or dividing. Now, we wrote this down a long time ago when we looked at relationships earlier on. I believe it was Unit 2, when we talked about ratios and equivalent ratios. But this still is going to apply here because if I know I have a smaller number and I'm increasing, which is going to be most of these that we do, then I know I'm going to be adding or multiplying or maybe even both. So if I have that in mind, that I'm going to be multiplying or adding, then I ask myself, well, if I have t plus something, can I get the c? So what can I add to t to get the 9? Well, in that scenario, then I have 1 plus, well, I would add 8 to it. 8 equals 9. So that's a true math problem. That matches, but can I repeat that pattern? So I replace the t with a 2. If I have 2 plus, that constant has to stay. So 2 plus 8, does that give me 18? No, it doesn't. So adding is not necessarily going to work here. So let's try multiplying. If I take t times something, can I get the 9? So I take 1, which is what we start with in that first column. 1 times 9 is equal to 9. Then I try it with the next number. So my next number, my next t is a 2, and I take 2 times, constant has to stay, so 2 times 9, does that give me 18? It does. That works. So just like in science, when I'm doing an experiment, I like to check it at least 3 times with the numbers that I'm given. So if I go to my third t-shirt that I could be buying and I multiply it by that constant of 9, do I get the 27 that they tell me? And yes, indeed, I do. So I know my rule, my relationship, what is being asked me to do is to write an equation. Then I know that if I take t times 9, then I'm going to get it equal to the c. Now, I could also write it 9t because that would also be the correct answer. All right, so when we get into this scenario then, it says the table shows the total cost of C, right? So that's going to be my dependent, my output. In the far right corner, keyword total means equal belonging to a gym for M months. So that's got to be my independent. I'm going to have to be figuring out how many months that we could be going. And it says to write an equation to represent the relationship between C and M. So what am I doing each month to end up with this total cost on the right-hand side? So using my independent, my M, to end up with my C, my final one. So I have to write a relationship, an equation, right? So how much am I being charged per month? Well, from the original problem, I would say, well, I don't really know. But let's look at the table that's being given, because the table indicates that I am possibly being charged $24.95 per month, because per month indicates one, right? So that's the idea of a unit rate. So we could try and see if $24.95 times the number of months is going to work. So I plug it in and I try the math. It's 24.95 times N equal to C, right? And it does. Each and every one that I work through, I would get that, yes, 2 times 24.95 is 49.90. 3 times 24.95 is 74.85. So I know that my rule is indeed 24.95 times M, or we can just write it as 24.95 M equals C. All right, so let's look at this two-step equations. This is where it can get a little bit tricky as we're processing through. Once again, it's just about identifying the important information, right? So when they set up the scenario, we see that we have B, the number of bats, we see a C for our total cost, and we're manipulating from one bat to a cost of 6. So I just am going to have to read closely to the information that's being provided for me. Then it says to use the rule 2b plus 4 to write the equation relating the two variables b and c. Well, they're just trying to trick you there, because all you have to do is be able to say, well, if I know that I have the relationship of 2b plus 4, and that has to be connected to c, and c is my output, then I just know that c is equal to 2b plus 4, right? Or I could say that 2b plus 4 is equal to c. So don't let them trick you on those type of questions, but it really comes from being able to read that information and create these charts. And that's what we're going to get ready to work through. When I see an example that I need to do, right, it says, this table shows the total number of necklaces that Ari has made after a certain number of hours. It says to write a two-step equation to represent the total number of necklaces N that she will have made after H hours. So when I start looking at this information, then I see that I go from 1 to 5. And as we looked at before, we asked, well, am I making, so much per hour? Well, then it would have to increase by 5. So that really doesn't work, right? So I can't just say, well, I'm going to multiply 2 by this certain number to get the final answer. It doesn't work for me. However, if I look at it and I say, well, if I take 2 times 1, and then I add 3 to it. So what we're seeing is that we started with a specific number already made, right? So if I already had 3 to start with, that's why that constant of I'm going to add 3 each and every time, which would be my second step to my equation. So I take my 2, I can make 2 per hour. I multiply it by how many hours I'm going to work, but I already had 3 in my back pocket or in my bag that I have all my materials in. And I add that 3 to it, then I can get to the correct answers. Now I know that oftentimes if we just read it and see it, it doesn't. Now I know that when the book gives you an entire page of reading step by step, and this is what you're going to do to get to the answer, that just seems a little overwhelming. So it's there for you, so you can read it. So go back, and in case you don't have access to the videos for me to explain it to you, but I know that most of us are going to be able to understand math better if we actually do it. So instead of throwing you to the wolves and making you do this check on your own, I'm going to take you step by step on how I did it. So once again, I don't use the answer key until I have created my own answer key showing all of my own work with my answers, just to make sure that I have the right answers written down. But I want to be able to explain the math to you, so I make sure that I can do all the math and I can explain it the best way that I possibly can. Keep in mind on your standardized testing that the first part of the test, you aren't allowed to have a calculator. So sometimes it is about doing a whole bunch of extra math on a piece of paper to figure things out. And that's what I had to do on this one. I'm going to take you through my thinking process as I did this question. And the first was I cubed up my paper. So here we are, we have the question, and we're going to mark it up so I know what my independent, my dependent are, and then build my math problem from there. It says that the table shows the total fees F. So I circled it, total fees. I know total is a key math term, so I box it in, and that means equal. And therefore, that's going to be where my answers are. That's going to be my dependent variable, so that's why my F column is marked over to the right. That's going to be my fees or my cost in this scenario. So the table shows the total fees F for D days. That's my second point. And I can see in my table that I have days and time listed with the variable D. So that's important as well. That's my independent. I'm going to have to use those numbers in my math problem. We're looking at an overall fee for library books that are overdue. And then they ask me to write a two-step equation to represent my total fee. All right, so find out a total cost, and I know it has to be a two-step equation. Now, sometimes sixth graders get to these questions and they just mark it up, and then before they read what they're asked to do, they're like, all right, so the previous question was about membership fees, and I had a unit rate, I think it was $24.65 or something like that per month, and this says 30 cents per month. So I'm just going to multiply by 30. Well, sometimes when I do trial and error and I'm looking at, just pieces and parts, I end up with a wrong answer. So I agree that if I multiply 1 by 30, it is 30. And I agree that since I'm going from a smaller number into a bigger number, like the previous note that I asked you to write in your book, then I have to be adding or multiplying. Maybe I'm doing both, right? So when I start looking at these, well, what can I do to get to 30? And I can see that 1 times 30 is 30. I can also do multiplication of 2 times 15, but that doesn't work for that first problem. So if I do 1 times 30 and I get 30, then I could say, oh, that has to be the right answer, and I move on. But I need to check my work, right? Since I'm writing an equation using dependent and independent variables, I have to see if it applies in all of those scenarios. And so I take my 2 for my D and I plug it in. And if I do 2 times 30, I get 60. But it tells me that I'm supposed to get 50 cents. So I know that that one step is not going to do it for me. So now I start looking at the idea, well, how about adding? What can I do to get to 30? Well, I can add 10 and 20, and I can add 15 and 15. And then I thought, well, I can go all the way to 1 and go 1 plus 29 and 2 plus 28. And that's a whole lot more work than I want to do, right? So I paused for a moment, got my thoughts organized, and I looked at it. I'm like, well, I'm going in bigger chunks, right? It's increasing by 20 each time. So I have that 10 plus 20. So let's see what I can do with that. We'll also try 15 plus 15. And this is literally what I did all over my scrap paper, especially because I was doing it late at night and I couldn't get all my thoughts focused. But I have to remember that I'm doing a two-step math problem. So I'd box that in because that's going to be important. So I know I'm increasing, and so 90% of the time, that means I'm going to be multiplying and adding to get to my answer. So let's use both of those, the 10 plus the 20 and the 15 plus the 15, and see what I can come up with. All right, so if I take 20 plus 10, that does equal 30. If I take the 15 plus 15, that does equal 30. But what can I be representing here since I'm going to be multiplying and I'm going to be adding? Well, if I think about what is being said in this scenario, right, maybe I have an initial charge, right? You're automatically late, so you're going to get penalized a certain amount of money. It's kind of like when you turn in a late grade, you're automatically going to get 10% off your grade. When I look at the idea of what is being done, then I have a total fee. Maybe there's a daily late charge that is being collected. So if I break down those two addition problems that they came up with and I think about the multiplication, maybe I'm saying that I take 20 cents and I charge that for every day that it's late, and then I add on the initial 10 cents for a late fee. And that would give me my 30 and that would work out. Or maybe I'm saying, okay, well then I know that it's 15 cents per day, and on the first day I had a 15-cent late fee, and that gives me 30, and that works out. So which one is going to be best? Well, then once again, like science, I want to do a couple of trials to see which one's actually going to work. So I go to my independent variable. I see that I have 2 days that it's going to be late, and I try the 20 times 2 now, plus 10. Well, at 20 cents a day, that gives me 40, and plus the original 10, that gives me 50, and that's what they tell me I should have. So I know that one works. What about the 15? So 15 times 2, so 15 cents a day plus the original 15, oh, that gives me 45, right? Because 30 plus 15 is 45. That one doesn't work. Well, I want to do a third trial just to make sure that I'm on the right track with the 20 plus 10. And so I plug in my next independent variable. So I know it's going to be 3 days. And if it's 20 cents for 3 days, well, 20 times 3 is 60. And then I add that original 10-cent fee for being late. Do I get the 70 that it tells me? I absolutely do. So by trial and error and working through it and thinking logically about it, then I end up with the two-step equation, which is required of 20 cents times D for however many days that I'm late, plus the original fee for it being late, which is 10 cents. That'll give me my total. It should be an F for fee, but it's my total cost of what my bill is going to be. And I know that was a long problem and a lot of explanation, but I really want to work through the thinking process that's going to happen. And sometimes it's going to take a lot of chicken scratches on your scrap paper in order to find the right. All right, so let's work through this example that they give us for one of our real world examples. It says each evening, Autumn and Bennett painted signs for a school campaign. The table shows the total number of signs painted after a certain number of hours. If the pattern continues, how many more signs will Autumn have painted than Bennett after painting for 9 hours? So I'm going to cube my math problem, right? So we have total number of signs painted, and once again, total is my answer. So that's going to be my outcome. So that's going to be my dependent variable, my output. We're going to label it T for total. And we're going to look at the how many hours we're working. So that's going to be my independent, and that number of hours that is working is going to change. So I know that that's going to be my input, what's being used. I'm going to label that H. I can also see that in the end, we're going to be working for a total of 9 more hours in our painting. What I'm being asked to find then is how many more signs will Autumn have painted than Bennett? So I have to find some information about Autumn, and then I have to find some information about Bennett, figure out how many they're going to paint in 9 more hours, and then subtract the 2 to find out how many more Autumn paints. So let's just look at Autumn, right? So we can see that we have 1 hour, we have 6. Now, we might think, well, my unit rate is going to there be 4B, that we can make 6 signs in an hour. But let's look at the pattern or the sequence that's happening. Going from 6 to 9, I'm adding 3. And then from 9 to 12, I'm adding 3. And from 12 to 15, I'm adding 3. So there's a consistent increase of 3 each hour. Therefore, I must deduce, I must infer that she started with 3 already. So what that tells me is that for every hour, I can actually paint 3, and then I have to add that original 3, that constant, and that gives me my 6. So when I check my work, 3 plus 3 is 6. That does equal correctly, but now I need to make sure that that is going to be the correct rule or the correct relationship. So then I plug in for 2 hours. And 2 times 3, because I'm going to be, once again, making 3 per hour, plus the original 3 that I started with would give me 9. Yes, it does. So I know that that's correct. And I just like to prove myself. I am, once again, in science, I like to do 3 experiments at once. So 3 times 3 plus 3, that would give me my 9 plus 3. That gives me 12. I know that's going to be the correct pattern when it comes to autumn. So if autumn had done it that many, now I need to focus in on Bennett. And when I look at Bennett and I see a 1 to 4, I might automatically assume that I can do 4 per hour. But let's look at the sequence, or let's look at the pattern that's happening. Going from 4 to 6, I'm increasing by 2. And from 6 to 8, I'm increasing by 2. And once again, from 8 to 10, I'm increasing by 2. So therefore, if I have 2 that I'm increasing by, but I'm starting with 4 on that first hour, I must have already had 2 done when it comes to Bennett. So if I use the same logic and I take 1 hour times 2 plus the original 2 I started with, does that give me the 4 that it says? And it does. But I want to check my math and make sure that my relationship here that I've created is indeed true. So I go to my second independent, which is 2, and I take my 2 times the 2, so 2 hours, 2 posters per hour, plus my 2 that I started with, so I end up with 4 plus 2, and that gives me 6. I'm good there. What about the 8? Well, my third hour times the 2 per hour, plus the 2 I started with, I have 6 plus 2, that gives me 8. I know I'm good. Now, going back to the question I'm being asked is, well, if we worked for 9 hours, so I have to plug in 9 times the 3 that Autumn is able to make per hour, plus the 3 she started with. And 9 times 3 is 27, plus 3 is 30. And then with Bennett, I'm going to plug in 9, but I'm going to multiply it by the 2 because he can make 2 per hour. So 9 times 2 is 18 plus 2 that he started with, I get 20. To answer the question, how many more will Autumn have than Bennett? I have to take after 9 hours, her 30, subtract his 20, and I find out that she had 10 more signs at the end of the 9 hours. Hopefully that makes sense and that seems logical. So let's do this final one before we move on and talk about the assignment. So this says, the table shows the total number of miles that Lan and Bailey have run after a certain number of days. If the pattern continues, how many more miles will Bailey have run after 6 days than Lan? So we have total number of miles, right? And total, once again, means equal. So I know that my total number of miles is going to be my T. That's going to be my output or my answer. And we're going to look at number of days, right? So if I have number of days and I want to look at my patterns on what's happening in order to figure out what my relationship is, because the question that I'm being asked is, how many more miles will Bailey have run after 6 days than Lan? So when I start looking at that pattern and I go from 1 to 6, it's not my unit rate, right? We're not doing 6 miles every day. So I have to find the pattern or the relationship, the sequence that is happening. So I'm adding 2 each and every time when it comes to Lan. 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12. So I know that we are increasing by 2 each and every day. Therefore, I had to start with a certain number that I added to 2. And then when I look at Bailey's, right, we go from 1 to 3. My unit rate might be that I'm 3 per day, right? But as I'm increasing by 3 each and every day. So when I start looking at what kind of relationships I might have then, I know that if I have 5 plus 2, that's going to give me 14 because I just have to go to my 6 days. And then I go to my 6th day and add another 2, then I can see that I end up with 16. If I continue my chart with Bailey and I'm adding by 3s, then I can say, well, on day 5, 12 plus 3 is 15. And on day 6, 15 plus 3, that gives me 18. Right? So this is just another way to approach these type of problems other than coming up with these relationships and these different algebraic equations. So if I know that Bailey ended up with 18 and Lan ended up with 16 and I subtract those, then I know that Bailey ended up with 2 more miles, right? Just a different way to approach it and look at it and filling out a chart. All right, so your question should be pretty easy, 2 through 10. There's only 5 math problems. This was a little longer video, but it's important that we understand how we are coming up with all of these things. We only have 2 more lessons when it comes to Unit 7, and that's, once again, just understanding how variables work and how independent and dependent variables work to come up with relationships and rules to follow. So as you're doing your assignment, if you have any questions, just please ask and know that we are here to help.